now. Something else I'll mention while that's getting buffered there. Memo is here, and we discussed this at the very end of class last time. I believe there is grant money out there to pay Memo to tutor you, which means he gets paid and you don't pay. So if you want to, you can contact Memo. Memo, is there a way they should reach out to you? Do you want them to contact you via email to schedule?
Yeah, email should be fine. Um,
Okay. Are you willing to dump that in the chat for them?
yeah.
Right on. And remember that Memo is here just to help you out. So we're very fortunate to have this. So I believe you can get free tutoring from Memo. So definitely sign up for that and schedule it with him. I think that's the deal, is it has to be scheduled. So if you ever want that, you've got it. Thanks, Memo. And anytime today, remember you could chat with Memo. All right, there he is. So any questions about that, I'm going to let you address it to Memo. All right, thanks. Um, oh yeah, so Guillermo is Memo. My bad. And let's do this. Oh, that's right. I'm going to share my screen. So first, I'm going to give you, these are all the terms that we're going to use. But what I'm going to do before we do the terms is I'm going to share with you a simulation here. Whoops. And so I'm going to talk a little bit about this. And Memo, I'm going to go ahead and mute you. You're good. And so I'm going to try and tell you why we should care about this, all right? So first, let's just get a vector out here and try and talk about what it is. Whoops. So a vector is something that has a magnitude and a direction. What? It has a size and which way it points. So in this problem right here, or in this picture right here, a vector is basically an arrow, right? Arrows have a length and a direction they point. So think of vectors as an arrow, okay? Now, we see that right here, this thing at the top of the screen, absolute value of A, that is called the magnitude. So that's the magnitude of a vector, all right? And I'm just going to write mag. That's the size. So if you wanted to think of it that way, that's how big it is, all right? The length of it. Now, this angle theta is the direction. So there's an angle at which it points. And if I could, I believe I can show you this. Whoops. I could put out a different vector here. And I think there's a way to show the angle here. Oh, whoops, I clicked the wrong button. All right, so let's go ahead and get the same vector here. All right, we'll just go like that. So in this case, you could see that there's an angle given. All right, and we could have different angles here. Notice there could be positive or negative angles. So there's lots of different ways to express a vector because every vector has a different size and length. Okay, great. Let's go back to this one. All right, in this case, now what we can see here is there's also these terms AX and AY. And I'm looking right here, AX and AY. Okay, AX is this distance horizontally. Notice that's 20 units. AY is 10 units. That's this distance vertically. So that's where these numbers come from up here. AX is called the horizontal component. AY is called the vertical component. Now, I'm going to undo a couple of these things really quick. There we go. There's a couple of different ways to show the components. One way is like this, and we see that there's an arrowhead on each component. All right. So notice each component is also a vector. Think about this. A vector is something that has a size and a direction. The components of this vector also have a size and a direction. So AX means 20 to the right. AY means 10 upwards. And you can see that this is true no matter where I put this vector on the page. Moving this little triangle around is not changing any of the components. So you could think of vectors as an arrow that you could put anywhere in space. And what I was thinking earlier is like you could think about applying forces to my head in different spots, right? And so the idea is you could push on my face with 10 pounds of force here, or you could push on it with 10 pounds of force here. that doesn't change the fact that you're still pushing with 10 pounds of force, in this case, whatever direction that is, okay? So you could apply the same force with the same direction at different points on an object. That's why we really care about this in physics. Later on, we're going to be doing complicated problems where we try and understand the motion of objects or why things do what they do. In order to do that, one of the tools is understanding how forces act on an object. Well, if we want to understand that, we first need to know the basic math of how to deal with these. That's the key reason this course is here, to make sure you're good at this stuff right here before you have to do physics with it. So we're going to start with this chapter, do all the boring math, and it's going to seem super boring. If you've had trig already, you might be like, oh, I know how to do all this. Well, watch out. You probably discovered on the quiz there are some things in physics that just seem and feel a little bit different and that require practice. Okay. Let's look at a couple other things here. Notice this. In this case, let's do this one here. Notice, where's my annotation here? Look at this minus sign right here. We see that when the arrowhead points to the left, AX gets this minus sign. Again, when the arrowhead points to the left, AX gets that minus sign. Similarly, if I go, whoops, if I work this thing downwards, right? Notice you get both of them have a negative sign up there, all right? All right, let me do that. And let me get rid of this. All right, and let's call that good. And let me get rid of these. There's a couple different ways you could show the components. So you can see there's different ways to do this, but we'll worry about that more later. Some of these, this one is really good in chapter 12, which is in Physics 161. We only do the first 6 chapters. So let's worry about that some other time. So let me get rid of all of those. Now check this out. This is kind of cool. Remember, I was just talking about forces, right? What if we had a bunch of different forces acting on something? Like this. And this is kind of crazy. You could say, or maybe it goes way over here to this, all right? The idea here, if I could get my annotation, and I'll do whiteboard work in a minute. Okay, here's the first, imagine this is the first force that's acting on me. Then there's another force that's acting on me, and finally a last force that's acting on me. The idea here is you could figure out the net force acting on me. So the sum, and notice the sum is right here. We're going to talk about this probably even more next time. We see that if you take the vectors and line them up tail to tip, tail to tip, tail to tip, what we get is the resultant or the result or the net force, something like that, however you want to look at it. Now, in order to do this mathematically, it's kind of annoying to try and draw perfect pictures all the time, right? That's going to take forever. So what we do is, if I could show you the components of each of these vectors, and I'm going to hide the sum for a minute. And let me maybe work this one a little bit so it's easier to see here. All right. And so, and let's make this a little bit bigger here. Okay, the idea now is if I want to figure out the net effect horizontally, I could take this vector, the horizontal part from A. I could also take this vector, the horizontal part from B, and finally this one, which is the horizontal part from C, and I add those all together. When I do that, I'll get the net horizontal force, okay? Likewise, I could take the green, these ones here, the verticals. I could take this much down, plus this much up, and that should give me the net vertical force. And so what's going to happen, we're going to discover we need to know how to go from the arrows to the components and back and forth. So this is the key thing that we want to learn from this. And what we see here is like this. The sum of these vectors, if I could, give me a second. This one came from all the other green arrows. this one came from all the other red arrows. And apologize if you're red, green, colorblind. So let me just say the horizontal came from all the other horizontals, and the vertical came from all the other verticals. All right. And that's what makes up this new vector. So the standard thing you do in physics all the time is you write vectors in one form, change them to another, do a bunch of math, then change them back. And one of the key things we need to do is get good at changing them back and forth, reading the different forms, and knowing how the different forms relate to each other. If we can't do that, we can't do physics. Questions?
Yeah, so is that the same thing as going from polar to rectangular? Is that what we're doing right now?
It's exactly the same thing. And
Okay.
yeah, good. And I'll show you that in just a second. Literally, the names are going to be polar and Cartesian form. Yep. So so if I could, let me clear all this. Let me get rid of this. And we'll get to this one. So this vector, if I show the angle, right, and then together, oh, come on. These two things, the magnitude and the direction, are called polar form. So if you've ever heard polar form, that's what that means. It basically means radius and angle. These two forms here relate to what is called Cartesian. And this is so slow for me. I'm just going to write cart. The spelling will be on the next thing we do. So Cartesian and polar. And so we want to get good at switching between Cartesian and polar. Esteban, you good? Excellent. All right. Let's go do some math now so that we actually see how to do these things. So let me get out of here. And I'm going to share a different screen here. Whoops, I forgot. I had it right here. Sorry about that. This is what we were just talking about, polar form, and there's the spelling of Cartesian if you needed it. So this is a slightly different vector, and I'm going to explain one in just a minute. But notice there's all these different forms, and so I wish there was only one thing to tell you here, but really you kind of need to know all of these. All right, and so I've got to move this zoom crap here. Let me see if I can make this a little bigger. All right. And so what I see up here, if I look in this vector, all right, and notice this angle right here is negative 60 degrees. And I guess I should keep the sig figs here, whatever. Okay, and so that's going to relate to something we see down below in a minute. And then this angle right here would be what, 300, let's see. Oh, just 300 degrees, right? And so we could see right away, there's lots of different ways to write this. And the red one was just down below. Sorry, I forgot to scroll down a little bit. I'll show you that right now. But I just wanted to point out there's many different ways to specify the polar form. For polar form, what do you need? You need a magnitude or a size, and you need a direction. So this is the size. In this case, the magnitude happens to be a velocity. Maybe this is a plane flying somewhere or something. All right. And this is the heading or the direction. So we see this has a magnitude and a direction. Likewise, here's a magnitude. Here's a direction. This is also a polar form. So it's not that they're both polar forms. They're just different ways to write it. Whoops. Let me clear my drawings here. Now, if I scroll down just a little bit, you can see this one right here is the third polar form. That's the one that uses the negative angle. I generally try to avoid the negative angle. However, because we're using Canvas, we are going to need that on the next quiz. So you do need to understand the negative angles too. Normally, I usually pick one of these first two forms. They're my preferred forms, but here we see we're going to need this. Okay. Cartesian form is going to be, that's the X components and the Y components. This term I hat right here, if I could make this bigger, the I hat if I could get my pen going, come on. This thing right here means to the right. Whereas j hat, this thing right here, means up or upwards, okay? Now you might be saying, wait a minute, this vector goes downwards, doesn't it? Look at this vector here. The components of this vector are, it goes so much to the right, and then it goes some downwards. And notice negative upwards is downwards. So the minus signs, we're going to basically use I hat is to the right and negative I hat is to the left. J hat means up, negative J hat means down. And the reason we do that is it's a lot faster to write I hat and J hat than it is to write to the right all the time, or to the left. Okay. And be careful. This probably won't matter in Canvas, but it will matter in at a paper test like your final. It's I hat. It's not I. I means the imaginary number -1 or current or something else. I hat means to the right. So do not just write I. You got to write I with the little hat when you do it. All right. I know I'm probably boring the crap out of you right now, but we gotta learn this stuff. It's hard to underestimate how much we're going to use this. So here's some other things that you could see. Here is a way to write the, let me get this out of here. Okay, so these are the vector components. You might remember that I said the components themselves could be vectors, or there's a thing called the scalar components. Now look carefully. If you include the I hat, that's a direction. It becomes a magnitude and direction. It's a vector. So again, if you include the I hat in here, we need to make it a vector. And so it's a vector. If you don't include the I hat, it's a scalar. Okay, that means not a vector. Notice there's no I hat. Notice there's no arrow. And those are the things we really want you to be good at so that you're not confused on homework questions in a real physics class, okay? All right. I've been talking a long time. I'm going to stop and get ready for the board. Let me see if there's any questions. And remember, you can ask Memo if you don't like talking to me. That doesn't offend me. I'll get ready to go here. Yeah, you can see what I was doing earlier. But any questions? Okay, if this is all easy for you, remember, you can always just start doing problems. Okay, you don't have to listen to me. All right, so hopefully that's visible on your screen. I'm just going to get this set up. Oh, ERT mode. Not fun for anyone, I know. Okay, that just gives me my rough limits there. Okay, so I'm going to start here with a vector. Let's have some fun. I'm going to call this east. You could also call it I hat. You could also call it X. So I'm calling this direction east or I hat or X. Those are the common ways I might write it. Can you see that all right or no? Is this black running out of ink?
You can somewhat see it.
All right, I'll switch. Is that better?
Much better.
Okay, so it's okay if these lines are a little bit light because we want them to be light anyways. So thank you for the feedback. So let's say we have a vector here and let's say this is, I don't know, 70 degrees, okay? Now you could have picked the other angle, but I want to do this one just for reasons that we'll learn later. I did the other angle in the earlier video, so if you want to see what it would look like with this horizontal angle, then you could go watch the other live stream. All right. And let's say this side is 16.4 meters long. Is that too small? Do I need to move it closer, or is it legible to you guys?
No, you're good. You're good.
Okay.
You can see it fine.
All right. So now let's just say this vector is Q. I don't know. Who cares what it is? So let's say this is a vector Q, and that's a little sloppy. And so this is a vector because it's got a magnitude and a direction. So our goal right now is just to learn the basics of going from this form, which is, think to yourself, what form is it? Polar. And we want to go to the XY crap, which is called Cartesian. Hopefully you got that. All right. So now the idea is I can look at this thing like a triangle. All right. Now I've kind of run out of room here, so I'm going to relabel it in a different spot. I just realized. I'm going to make my triangle up there, so I'm going to label it here. I think I said this was 16.4 meters, and this angle's 70 degrees, and I need a little bit more space. So I'm going to scoot this down. And just so we have sig figs, why don't we call this 70.0 degrees, okay? All right. And it's maybe not to scale. Now, here's the thing. There's going to be some vertical component this way, and that's going to be the amount of Q in the Y direction. So that's going to be called Q subscript Y. There's also going to be some Q subscript X. And so we see now that we've got two components, QX and QY. Now, I know you're new to this, so you might be wondering, wait, did he want to leave the arrows off this or not? And I do. So here's the deal. In a physics class, things are a little different than a math class. What we want to do here is this will be the size of it with no direction. So this is going to be a positive number, and the arrowheads in physics are going to tell me whether it's positive or negative I hat, J hat crap. So in this case, notice QY is going to be some number positive. QX is going to be some number positive. This corresponds to positive J hat. Think to yourself, this would be then positive I hat. All right. And in the end, our goal is to rewrite Q in this new form. We want to rewrite Q is equal to something in the X. In this case, it'll be some number in the I hat plus some number in the J hat. And to be clear, the number here is going to relate to the blue stuff. So maybe I'll do this in blue. There's going to be some number here. It might be plus or minus. We'll worry about that in a minute. And like I said here, this is going to be some other number. It's going to be some number, and maybe it's plus or minus. We don't know yet. So basically, our goal is to figure out these numbers using trig. All right. Now, if you haven't done trig before and the sound of me uttering that is scaring the crap out of you, don't worry. I'm going to show you how to do it. And if you know how to do it, just start doing problems, okay? So that's our goal. How do we do this? Well, look at this triangle here. We've got a triangle, and what I'm going to do is just redraw it without the arrows. Okay, and this we said was QY. This we said was QX. And now something you're going to see me do, this side is the magnitude. So I'm just going to call that capital Q. So this is the size of it. So again, Q with a vector, I'll call that Q vector or Q the vector. And this has got a magnitude and direction. The sign of this, or the size of it, sometimes you'll see books use a double absolute value sign for vector norm, whatever. Yeah, this is the same thing as Q. So these two down here are the magnitude. This one is a vector. So just be aware of that. So if you're ever not sure, or if you ever think I forgot an arrow or an I hat, just hit unmute and say, dude, you forgot an I hat or did I do it? I'll be like, let's check, and we'll just figure it out together, okay? So don't be shy about chiming in on that kind of stuff. So again, we've got the magnitude and the two components, or the sizes of them. I know this side is 70 degrees, but since it's getting kind of hard to fit this in here, I'm just going to label this as theta. So that's my angle theta. Now, let's say I want to figure out this side of the triangle. I want you to think to yourself, should I use so, ka, or toa? And if you don't know what that means, that's okay. I'm going to show you. But just think to yourself, if I want this side of the triangle, the y component, I've got the magnitude, I've got the angle, think, what should I use? All right.
Should be sine, no?
No. And so
No?
once again, we see the joys of physics. So this is, now look, you're used to a math class where the y coordinate always gets the sine. I deliberately chose this angle because anytime the angle is drawn to the vertical axis, that flips sine and cosine. And this is actually going to get cosine. Let me show
Oh,
you what I
yes,
mean.
right. Yeah, I see it now.
And maybe now you recognize why I put that on the Canvas math quiz, just to show you, like, I hate physics. All right. So you learn early and you're like, crap, this is no joke. Okay. So look at this. Cosine of theta, that's going to be adjacent over hypotenuse. So if you don't know trig already, there's this phrase, so, ka, toa. And what this means is, ka means cosine of theta gets adjacent over hypotenuse. And if you need extra help on that, definitely stick around in office hours and I'll go slower. But for now, all we need to know is cosine of theta is this. We'll take a look. Instead of plugging in the numbers right away, let's use the letters. Adjacent to theta. So we see that this angle right here is the right angle, which makes this side the hypotenuse. So this is the hypotenuse of the triangle. This side is adjacent. So notice it's QY. And then over here, the hypotenuse, I think I just said that, that's Q. All right. Now, from here, I could actually solve this. I don't need this piece anymore, right? Because we used it. So I'm just going to scoot this over now. And now, if I solve this algebraically, I can multiply both sides by Q. And this is what we're going to do most of the time. We're going to skip right to this step. I see that the Q's cancel out. And I could rewrite this as all right. So notice in this particular case, QY is Q cosine theta. All right. Any questions about that? And I'll check the chat, see if there's anything in there. Okay, got it. All right. So now I'm going to erase that work. We did ka. So now we could do sine. And I'm just going to do this one a little bit quickly. So sine is opposite over hypotenuse, which in this case is opposite of this angle, QX. And these are the most two common ways we use trig. So this is all, it's not all the trig we're going to need, but we'll talk more about it here later. So this gives us an idea how to do this. And if I do all the work for this one, hopefully you see that this is going to end up being Q sine theta, just like that one was Q cosine. And again, had I used this angle right here, this angle is 20 degrees. And so had I used 20 degrees, I could have said QY is equal to Q sine of 20, right? Because this would have been opposite. Whoops. You could see a different way to do this one right here. Like this. Notice this red side is the same as that red side. So QY could also be written Q sine of 20. And so if you get used to this, it's not that bad, but you do need to know anytime the angle is up here drawn to a vertical axis or down here to a vertical axis, the sine and the cosine will be flipped from the standard way you've seen it in a math class. All right. And again, what am I trying to do here? I'm not trying to worry about the minus signs. I'm just trying to get the size of it. Now, you might be saying, well, Professor George said, I like to use this angle over here. Maybe you like to use this giant angle, which is what? 160 degrees. Good for you. All right. And that's fine. And there's a time and a place for it. And I'll discuss that in a few minutes. Now, there's some challenges with that. And let's leave it at that for now. So I don't want to open up that can of worms yet. Right now, I'm just trying to get the sizes. And this is very common for physics. We need the size of these components, not the size with the sign. That's what this angle is good for. Okay. All right. Out of all that, oh my gosh, I'm kind of getting lost here. This is getting messy. So let me clean this up a little bit. Okay. Apologies here. So now I'm ready to grab my calculator. So notice we did a lot of work without grabbing the calculator. That's key in a physics course. Usually the longer you wait to grab your calculator, the higher your physics grade is. Now that's not always true. You know, if you have numbers in a test question, feel free to use your calculator right away. But generally speaking, you're going to learn it's easier to check your math if you do your work without the calculator as far as you can, than at the very last step, plug in your numbers. That is really a big deal. Okay, I cannot emphasize that enough. So I'm going to punch in my numbers here. Let's see. We know that Q is 16.4. That's the size of it. And this angle is distracting me, so I'm going to get rid of that, okay? And this too. All right, so now we're kind of back to it. I think I lost a subscript over here. This was Q subscript Y. So again, we've got QY here, QX here. This is the magnitude. That was Q. All right, so go ahead and try and beat me to the punch. Try and figure out QX and QY, just the numbers. Don't worry about the sign. Okay, so what was it? 16.4.
I got 10.39 for QX and 12.69 for QY.
Okay, I'll double check as well.
Hopefully I did it right.
So I got, let's see, what did you say for QX?
10.39.
Okay. What was it? 70 degrees?
Mm-hmm.
Let's see. I got 15.41.
Wait, am I in? Hold on. Let me make sure I'm in
Check
degrees.
you're in degrees. Let's see. So this is something, and this is the kind of thing that you got to look out for. So notice if you hit the mode,
I was in rads.
Yep. So there's a mode button right here, and that allows you to change between degrees and radians. So in a math class, very oftentimes you're using radians, and in a physics class, we use both. All right, so watch out for that. So I got 15.411. Okay, and then we could round this later. Is that right?
That's what I got, yeah.
That's wrong,
15.
though. Why is it wrong?
Sig figs.
No, let's let somebody else, Esteban. You're right. There could be sig figs here. Absolutely. So somebody other than Esteban, just to get other people involved. What do you think?
There's no units.
Yeah, because this had 60.4 meters. You got to remember to bring the units along. Don't you love physics? All right, and I'm going to check the other one real quick. What was it? Cosine 70. So I got 5.6 for the other one. 5.609. Meters. So remember, you got to keep those units along. And now because this had 3 sig figs and this had 3 sig figs, Esteban was absolutely correct. I did not display the sig figs correctly. And so by showing the underline, that's just saying, okay, and the reason you do that is, what if I need to use these in another calculation? You don't want to round too early or Canvas will screw up your score, okay? And it's just bad practice. All right, yeah, we should not be worried about Canvas. That should not be the reason we do anything in life. Canvas is stupid. Now, we should do it if it's the right thing to do. And in this case, it's the right thing to do. All right. So it's the right way to do work. Keep that extra sig fig. That's why we're doing it. So finally, after all this, geez. Oh, we're done with class, but let me write out this. This is the last little bit. Now, look, we know this size. and it's to the left, right? So it's, I'm going to write this, negative 15.41. I don't need an extra one really, meters I hat. The minus I hat came from right here. That's where the minus I hat comes from. And then we have, I think, a plus J hat. So that's going to be plus. And I guess if you wanted to, you could factor out the meters and stick it out there. So you could do it like this and stick the meters out here at the end. All right. And so that's our first vector. And now I know we're a little bit over. I apologize. I'm going to stop the live stream, but I am going to tell you a couple of spots in the book and some things you could read for next week. All right. So again, I'm sorry I ran over a little bit. All right. So let's stop that.